Okay, so welcome back. This is part 3 in our series where we help you to understand what are relays and how do they work. Now, I encourage you to look at the first 2 parts in the series. We talk about the basic concepts behind protective relays and why they're needed, and that they're used basically everywhere in the commercial industrial world. And in fact, the power lines that feed your home or office are protected by protective relays. And the goal of a protective relay is to monitor a circuit like the electric power lines feeding your home, and when it senses something wrong, a problem or a fault, it will generally start a timer, and if the fault persists, when the timer times out, it will initiate an action. And generally that action will be to open a circuit breaker, which will de-energize the lines feeding your home or office and cause the power to go out. And it will also remove the fault to protect the circuit in case it, so it doesn't catch on fire or cause any damage. Now, there are other types of relays we're going to talk about in the future. There's control relays, but here we're focusing on protective relays. And we've started to build in part 2 this simulator that is simulating a real-world protective overcurrent relay. And in this video, we're going to look at another feature that we've included in this simulator, this relay simulator. And again, it's really important if you want to understand engineering or scientific concepts that you spend the time to figure out how to write a software simulator, because then you have to really get down to the nuts and bolts and figure out how does the thing actually work. That will really help you to understand what's going on under the hood. So we started in part 2 to build this software simulator of an overcurrent relay. And in this video, we're going to look at another feature and function that you often see in protective relays, and that is called a digital fault recorder. Now, what is a digital fault recorder? Well, as you can imagine from the name, it records faults. We said the purpose of a protective relay is to sense when a fault occurs on a circuit and initiate some action like opening a breaker. A fault recorder merely monitors the circuit, and when it sees a fault, it records that fault for future review. Now, why do you need a digital fault recorder? Well, if you have a problem on a circuit, for example, if the circuit's feeding your home or your neighborhood, if there's a problem and a relay operates and trips the breaker, that will turn off the power to you and all your neighbors. That's not good. So somebody has to fairly quickly figure out what happened and find out where the fault is. And once they find the fault, they need to fix it, and then they can turn the power back on. So a fault recorder is a really nice feature because it allows you in certain circumstances to look at what actually the fault current was, to record that so you can look at it and say, well, the fault current was really, really high, which means maybe the fault was really close to where the relay is, as opposed to if the fault current was really, really low, means it's far away. So it might be able to help you figure out where the fault was so that you can go and you can repair it. We've got here a DFR or digital fault recorder function in this relay, and let's see an example of how it might work. So what I'm going to do is I'm going to go to the bench and increase the current. You can see there's 0 current going into our relay. I'm going to increase the current to the point where this trips, and we can see what the DFR does. So now I'm increasing the current on the bench from the DC power supply, and you can see it's increasing, and it's up to 5.5 amps, and the relay is timing, and soon it's going to trip, and we'll see what the DFR gives us. So the relay has just tripped, and let's take a look at the DFR. So the current went to 0. It took 11 seconds for the relay to trip, and it opened the breaker and turned off the power. Here is a DFR button. This is our digital fault recorder functionality. So if we click on it, you can see, it has the current in the circuit from the time the current was at 0, and it increased up to a little over, just around 5.5 amps, and then at this point it tripped. And this is how many seconds in this simulation. So somebody can now take a look at this chart and say, oh, it was 5.5 amps, and that may help them to figure out what the fault is or where the fault was. So it's a really useful function that is included in many protective relays. Now, this function may also be included in a separate device, a separate digital fault recorder that allows you to monitor not just one relay current, but multiple circuit currents so that you can compare them, and that might help you even more to figure out what the fault was or where it was. So now let's take a look at the DFR functionality that we've added to this relay simulator. So now you may be thinking, well, to implement a digital fault recorder, really all it does is it senses when in this case, when the current exceeds a certain value, or minimum trip. All we do is we start recording the readings, the current and time readings, and that's about all it has to do, right? It just records them in a set of lists and then sends it to a chart. Now, if we look at our DFR record, we also can see that we've got some information prior to the point that it exceeds the minimum trip. In our case, 2 amps or 3 amps. It has what's called pre-fault data. So somehow we're going to have to figure out how we can not only include data after the fault occurs, but it gives information on what was happening just prior to the fault, and that can be very useful. So it's not going to be just simple recording, it's going to be figuring out how to do pre-fault recording of data before the fault occurs. So that's going to take a little bit of logic. Now, another thing we're going to have to do is we're going to have to figure out, when we hit this DFR button, you can see it brings up another form that has a chart on it. Now, in another video, we talked about how to do this, how to set up 2 forms where we press a button, we open up another form with a chart. So I encourage you to take a look at that. But in this video, we're going to show you how to read the data, get some pre-fault, and then transfer it to this chart in another form. So here is the solution for our relay simulator. This is our Form 1 that's got the interface, and I've added a Form 2. We talk about in another video how you can set up a second form that shows the chart. And here's our Form 2. It's basically just a form with a close and a chart. We'll talk about that in another video. In the previous video in the series, we talked about this overcurrent relay class. We go through, it's got properties, constructor, methods, event handlers, and basically this just reads the current in from the Arduino and the current sensor and determines whether there's a fault, and if so, goes through and times out and ultimately trips a circuit breaker. We also have this SCADA class, which is public static class that holds a little bit of information that everybody can access. What's the simulation time in seconds? What's the time step? We're having a time step every 1/10 of a second or 100 milliseconds. And this is the line amps. So every time we read from the bench, it stores the data in this line amps, and we have all of this stuff available to everybody. What we're going to talk about in this video is this DFR class. I've added a class to our project, right-click, add new class, and it's called DFR, or Digital Fault Recorder. And it's a very simple class. As we said, all it has to do is it has to store the time and the current for each reading. So I've got a list of doubles, DFR time and DFR amps. And when we sense a fault, we're just going to start recording in these lists. We're going to add to the list each time step a time and current value. Now I've got a public double, which is the minimum pickup. Again, it's going to start recording when we have exceeded some current minimum pickup, which is this. We also have a public integer pre-fault, and we're going to use this to store our pre-fault data. We're going to use this integer. We also have a Boolean, whether the fault detector is picked up. Again, this is going to start recording as soon as the fault current goes above this minimum pickup. And if it's recording, it's going to set this Boolean equals true, fault detector picked up. Now, public class DFR, so I've got a constructor here that basically instantiates the DFR time and DFR amps as new lists of doubles. So the only method we've got in here, which is what's called every time step, is very similar to what we've got in our overcurrent relay. And that is an overcurrent detector. So it basically takes the reading in from the Arduino, checks it versus the minimum pickup, and if it's greater than the minimum pickup, it starts recording. So here is all we've got in that method. This method is called each time step. It has logic to grab time and amps each time step and store in local lists. It also contains pre-fault logic, which we'll see in a bit. When the chart button is pressed on Form 1, it passes these local DFR time and amps lists to Form 2 where they're bound to the chart. So again, we're recording this data, and when the fault is finished, when the relay has tripped and opened the breaker, we're going to pass this data that is recorded to Form 2 where it's going to be charted. This method also stores a minimum pickup value, which is passed from the user input text box in Form 1 when the Start Simulation button is clicked, and we'll talk about that in the future. So again, overcurrent detector, public void, and we're starting out, we are incrementing this pre-fault value. So the pre-fault value is basically going to store, in our case, 5 seconds of pre-fault data, and we're going to use this pre-fault integer to determine when we have stored 5 seconds of data, and each time step it's going to increment this pre-fault. So each time step, when we call this overcurrent detector in the DFR, it's going to add the simulation time and the line amps that are stored in the SCADA class. All right. So every time step we add the simulation time and the line amps to this SCADA class, and this DFR is just going to grab that data and store it independent of whether the fault detector is picked up. All right, so every time step it stores the simulation time and the current. We are now figuring out this mult-MT is whatever the line current is divided by the minimum pickup. So that's to determine whether the current that we're reading has exceeded the minimum trip value. So basically the ratio of the line current over the minimum pickup is the multiples of minimum trip. If the multiples of minimum trip is greater than 1, then we're saying the fault detector is picked up. So if it's greater than the minimum pickup, then the fault detector picks up, and now we know we have a fault. Now, right here is this if statement, and this if statement is all we need to store the pre-fault data. This will store only 5 seconds of pre-fault data. That is 50 readings at 0.1 seconds per reading. So again, this is going to be called every time step. In our case, it's 100 milliseconds or 0.1 seconds. And it's going to add to this DFR time and DFR amps. So let's think about how we can do pre-fault. One way we can do it is every time step from the start of the simulation, we can just store the time and the current. And that's fine, but I mean, if you do this for, a few hours, you can have thousands and thousands of readings. So it's better if we can figure out a more efficient way to just store some pre-fault data. And what we're going to do is we're going to store it in a window, a moving window of data. So we're going to have to figure out how we can store, say, only the latest 5 seconds of data in like a moving window. And that's what this if statement will do. So recall, pre-fault is incremented each time step. If pre-fault is greater than 50, so 50 readings at 0.1 second per reading gives you 5 seconds worth of data. If the pre-fault is greater than 50 and the fault detector is not picked up yet, then what we're going to do to make the window is we're going to add the reading, but we're also going to remove the 0th element. And that will give us a moving window of 5 seconds of data. So over 5 seconds or 50 readings, we're going to keep removing the 0th element. We're adding an element, the latest element, but removing the 0th element, which means we are maintaining a 50 element list of data of time and amps as long as the fault detector is not picked up. So no fault, we're just storing 50 elements in the time and current lists, which means we are storing 5 seconds of the latest data. Now, as soon as the fault detector picks up, we're not going to go into this if statement anymore. We're not going to remove the 0th element. And we're just going to increment, we're going to add to these time and current lists with the latest value, but it's going to maintain those 50 elements, or that 5 seconds of pre-fault data. So a nice compact way to have a moving window of, in this case, 5 seconds. And as soon as the fault detector picks up, we're going to stop removing the 0th element and just add the latest elements. So that's how we're going to get our pre-fault data. And that's basically it. This is all we need for our digital fault recorder. You can add functionality, but in our case, that's about it for the digital fault recorder. Now, in future videos, we're going to show you how to integrate this overcurrent relay class we talked about, the DFR class, and integrate all of that into our form and make this all work. That's coming later, but now we're just looking at the basic components to see how we can do it. So I encourage you to also look at the other videos that show us how to implement, for example, these breaker open and closed images. And we're also going to do the same for this fault image, and how to do these radio buttons. So I encourage you to take a look at those. And also we have a separate video on this user interface, which is simulating an LCD display. And we're going to use what's called a rich text box. And I encourage you, there's a separate video to show you how to do that, so we can have different fonts and different updates of the rich text box. So if you like any of these videos, please hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.